With the statistics. In this class, we are going to discuss about the probability mass function and its conditions, and also the definition of a continuous random variable and random variable. A random variable is a function of uh, random variable is a real valued function defined on each and every outcome of the sample space connected with the random experiment, which we already discussed. Next, consider a random experiment of two tosses of a coin. Then the sample space is already given. So here x is denoting the number of heads. So the random variable x can take the values of 0 heads or 1 head or 2 heads. There are 4 outcomes of the sample space. The probability of x is equals to 1 divided by 4 and 2 divided by 4 and 1 divided by 4 respectively. Next, coming to the another experiment, an experiment consisting of rolling a die. The sample space is 1 2 3 4 5 and 6. So the sample space becomes the s value. Let the random variable x is the number of points are to be turned up. So what is the probability of that? For each case of the random variable, that is 1 by 6, and also x takes the values is 1 2 3 4 5 6. Next, the types of random variables. There are two types of random variables, that is discrete random variable and continuous random variable. Discrete random variable is having the finite range value, excuse me. So a random variable x is called a discrete random variable if its range space R of x is finite or countably infinite. Later, the some of the examples: the number of heads in tossing of 3 coins, the number of defectives in a sample space of n items, the number of accidents per year. Discrete probability distribution function, or we can say that the probability mass function. Let us consider x be a discrete random variable which assumes the values of x1, x2 and so on xn with the respective probabilities p1, p2 and so on pn. In general, if it p of x is said to be the probability mass function if it satisfies the following conditions. First one, p of x I is always greater than or equals to 0 for all I values. Summation I runs from 1 to n, p of xi value should equals to 1. So this is one of the example problem. A random variable x has the following probability function. So verify the properties of the discrete PMF. So what are the properties? P of x should greater than or equals to 0. Summation I running from 1 to n, p of xi value should equals to 1. So where I equals to 1 to 3. So p of x1, p of x2, p of x3, they are given 1 by 4, 1 by 2, 1 by 4, which are all greater than 0. Summation I runs from 1 to n, p of x should equals to 1. So the probabilities are 1 by 4 plus 1 by 2 plus 1 by 4, that is equals to 1. Hence it is verified and it is the probability mass function. Now see the random variable function also. A continuous random variable. A random variable x is called a continuous random variable if its range space R of x is uncountable or an interval. Age of a group of persons, temperature recorded in a city, the rainfall overhead day in the hills areas. So it should be the some conditions that is f of x should be greater than or equals to 0 for all values of x, and integration over f of x into dx is equals to the value should equals to the 1. So next so here is one of the example. Verify the following density function or not. F of x is equals to 2x, where x is lying between 0 to 1. 4 minus 2x, that is x is lying between 1 to 2, otherwise it is 0. We need to check first of all f of x should greater than or equals to 0, and integration over minus infinity to plus infinity f of x into dx should equals to 1. So here you can substitute the values of the lower limits and upper limit also. So 0 to 1. So all the function values are also be the greater than 0. So the second condition, so minus infinity to plus infinity value, it could be the given limits are 0 to 2 value. Okay, so 0 to 2 we can apply. Then after we got the value of this integration is 2, which is not at all equals to 1. So this is not at all a PDF. Next, verify whether f of x is probability density function or not. F of x is equals to x by 2, where x is always lies between 0 to 2. So f of x should be greater than or equals to 0. Then f of x is a probability density function because the integration value we got here is that is equals to 1. So like this we have to check. Next the distribution function of a random variable. This is very important. Let x be a one dimensional random variable. The function f is defined for all the values of the real number values of x. So the f of x is p of capital X less than or equals to small x is called distribution function of a random variable. The summation for the discrete, the integration for the continuous. Properties of distribution function, these are very important. F of x is the distribution function of a random variable x. If a less than b, then the a less than x less than or equals to b, f of b minus f of a. Proof of this, uh, the event a less than x less than or equals to b and x is always less than or equals to a are mutually exclusive events. Their union is x less than or equals to b. So x less than or equals to b is equals to x less than or equals to a union a less than or equals to x less than or equals to b. Applying probability on both sides, then we will get by the addition theorem of the probability or the axiomatic probability definition. So p of x less than or equals to a plus p of a less than x less than or equals to b. The events are disjoint. So this is could be f of b minus f of a. So hence the theorem is going to be proved, or the probability of that value f of b minus f of a. So similarly, the second property and third property also you can see here, and fourth property also, and fifth property also, and sixth property is also be there. Okay, you can see this. Okay, next we have some simple and easiest calculation of the formulas for the discrete and also continuous random variable, like this. Yeah, up to the problems are over, the formulas are also over. Next class we are going to discuss some other things. Thank you.